Well, morning on this windy and noisy day. Today I'm going to be giving away my GPS assisted ionizing radiation survey meter. This is made for a specific project and there's a whole playlist around that which I'll link below. But yeah, after I built this and did a basic survey of a particular area for a single project, I discovered I could buy a Radiocode 101, which was great. Until things got popular, like the release of the Fallout series, and Radiocode started doing promotions. So now I have a Radiocode 103 and a 101, along with a bunch of other Geiger counters. So this one is a little surplus to needs, but somebody else is that I know is looking for one, fan of the channel. So we're going to open this up and change the batteries. And the batteries that should be closer to 12 volts are looking more like 7 volts at the moment. So we do need to change them. Make sure it's ship shape, find all my design notes and everything all over again, and get them off to him. So let's crack this open, do a battery change. Now, this wasn't really designed with regular battery changes in mind, and you can power this off an external 12 volt supply, but the Geiger counter batteries are separate. Just because I couldn't be bothered making a 3 volt regulator to swing off the 12 volt batteries. The 12 volts is basically to run the Raspberry Pi Zero that's part of this project. Now we need to lift this off gently and spin this around. So we see 12 volt battery pack in here, 3 volt battery pack here. Hopefully none of them are leaking. We have a GPS module, we have a real-time clock, a whole bunch of other stuff in here. This is all noted. GPS antenna. I was putting this together too at random at the same time as the GPS epoch happened. So I had some whole issues with that as well. And random bits of tape here, I think, just to keep connections off stuff. Anyway, let's get on to these battery changes. Okay. This takes 10 AA batteries all up. So let's swap all these out. Alright, so we have up here the 12 volt battery pack. And there is a regulator. It's got the 9 volt stud type clip on it. That could work potentially off a 9 volt battery, but not for very long. And I put some tape on here to stop it shorting out on the board underneath, which is sort of helping with removal of batteries. And I see a leaky one in here, so that we will have to clean up. But I was pretty well on the ball with that. Now, I don't know which batteries have just rolled off on my lap, so I need to go and test these two batteries, figure out which is which. Okay, I identified the flat battery. That can go up there. Alright, we will need some contact cleaner on here, probably, although it looks like it hasn't really got to the contacts too badly yet. Either way, I still need to peel this pack up, change the other 4 on the other side as well. Alright, we're going to peel this off. That helps. Now, we should, if all things are equal, be able to move these wires around just a little bit and lift this pack out, which is just stuck in with Blue Tack off memory. Blue Tack being a Bostik product. Okay, there we go. There's 4 batteries in here. Okay. There we go, clean up our battery pack. And I did use it this way specifically so you can actually replace the entire battery pack assembly if you get some crook contacts. Makes it much easier. You can go and buy these from Jaycar. Now the contact that was against that leaky battery doesn't look too bad, but it's not like an integral battery pack. You can change it, as I said, so we're not too stressed about that. Now, sometimes on this channel I make the assumption that everybody knows how to do something. I'm regularly proven wrong. When installing batteries, this is the negative end, this is the positive end. The negative goes against the spring. And you put them in series, that's why they alternate, so that they are linked together at each end here. So they're all in a single string. So when you put batteries in series, the voltage adds up. If you put them in parallel, in other words, you connect all the negatives and positives, you end up with an increase in current. I'm going to have a little bit of a gaffer tape here. And we just sit that across the top. Okay, contacts can go over that way. can drop back in right next to the GPS module, and we can plug in. And also the reason why I put such big tall guards on here is so that I can literally flip this upside down and not squash the switches. Right, now we move over to changing the batteries on the Geiger counter module, which is, again, this pack is stuck in the Blu-Tack, but this one doesn't have a connector on it. So we have to just pry it up gently, and we're going to use a spudger tool. And I put the good long life batteries in this one so that it lasts a bit longer, and because the current demands on this one are slightly higher. Now for a project like this, if it wasn't using such a high current demand, I'd put dry cells in. They last a lot longer. I don't know where my industrial grades have gone, but I have some actual Duracell alkalines. They can go in here. Whoa, things are falling off. Plonk you over that side, and then we'll plonk that back down in there. Just stick down with the Blu-Tack. Okay, and that should drop over like that. All go together. I just want to make sure all the wires are in an appropriate position there. And these use captive screws. I'm going to do up 2 screws just gently, and then I'm going to test that things work. Now, I've gone to close things up, but I noticed something. Aside from the wire that I had to push out of the gasket side of things, which really isn't important because there's a big vent in the bottom, but this bit of gasket here was misaligned. Anyway, so let's put this back on. Now, normally this would be like weatherproof, but because of this big vent here, like, yeah, if this gets wet, water can get into it. So not something you really want to do. Now, there is another aspect to this that is important. There is a Raspberry Pi Zero in this, but the Raspberry Pi Zero is built inside this monitor base, and there's also the USB ports hanging out the side to interface with it as well, if you want to put a keyboard or like a USB Ethernet adapter or something like that. It does have Wi-Fi, but yeah, to be able to interface with it, you may need to plug in a keyboard and mouse. So let's get the rest of these screws done up. After we have a quick inspection that there are no wires stuck in the gasket, and we'll do it all the way up, and we should be good to go. Okay, so let's fire this thing up and see what it does. So what we need to do here is turn on the unit, turn on the display, and we'll turn on the counter as a separate unit. Let's let it do a boot up. Alright, we're booted up here, and it's going to tell us what the count rate is based on the counts per minute. It's a bit of a I do it by 15-second intervals to do the counts, and then multiplied by 4 to give us counts per minute. Probably not the correct dose rate, and it makes an estimate of microsieverts per hour, which is obviously off because the background here is usually about 0.05 or thereabouts. So the maths may be wrong. That can be altered in the code. It's just a Python script. Easy to modify, easy to correct. I have it logged to a CSV file, which records the counts per minute as an estimate on there. It does settle down over time. It'll calm down. But what we might do in a minute is put something radioactive near it. So we have some thoriated tungsten electrodes. We're going to stick them underneath the tube down here, and it should certainly increase its count speed a little bit. And it's going to start to tally it up a little bit more. The GPS takes a little bit of time. I think I have a mute button on here too. I think if I hold that down, it mutes the... I think that's it. Does my mute button not work anymore? I've got another button to shut down the Pi as well. In either case, it'll add the count up. This is probably the maths definitely needs to be changed. Anyway, we'll remove that from under there. But yes, this button here should mute the sound on it. It doesn't always, and it could be just that the little DuPont connectors come off when I change the batteries. Don't know. We have here, this button here should shut down the Raspberry Pi module, and it should go into shutdown. Then you can turn off the monitor and you can turn off the battery. The battery has a voltage readout here, which should be around about the 12 volt mark. We can shut that off, and the counter can run independently of all of that, so you can just shut that down and we can just run the Geiger counter off its own switch here, which is why I've got separate batteries for that. Anyway, we do have our strap stuck in the monitor here, so that's pretty much it. This strap can be used or taken off, but yeah, that's pretty much it. This is going to go to a new home and hopefully be loved for a greater amount of time than it did with me. I built this, spent months building it, went out, did one survey with it basically, and that was its entire life used. Nowadays, when I want to do stuff, the Radio Code does a way better job. So, and I have a spare one of those counter boards that I made built into the desk in the background here as well, running on this analog dial. So, interesting stuff. Bit of a break from the Land Rovers, but I hope it was fun.